Hey guys, am I audible, visible? If so, say me a hi and a comment, please. Comment. Good evening, everyone. So, how are you guys doing? You must have had an amazing introduction to microbiology by Dr. Mamta. I hope it is good. So, am I audible, visible? Good evening, Ankita. So today we will be starting with cell cycle. Every day I have already put the entire week schedule in the Telegram group what we have, and we'll be going accordingly. So I want you to listen to this lecture. I won't exceed any day beyond 20-25 minutes. Let's keep it at 20-25 minutes. After finishing this lecture, go back to Robbins and read. Right? I have given the workbook also a simple tiny single page PDF. So if you are taking e-notes, take in that, or if you've taken a printout, take in that. Fine. Good evening, everyone. So let's start. Okay. So why I wanted this RRR session to be there is if you are not being with me and if you're not being a part of Meded or anything, like we have to make sure Robbins is doable. Which means if I take notes of Robbins and make them like a note of whatever book you follow, be it your Harsh Mogan or be it your Ramdas Nayak, anything, right? So if I can make Robbins like that, if you can do that, it will be much more comfortable. That's the entire goal here. So how I will structure every question here is, we'll have a tiny heading of definition. There's nothing but the first two lines in Robbins in the topic, that's all, right? Need not help, sir. If you are there, Nishay, please go with the same thing. I'll be doing the same thing. If you have extra time, no, read here and revise in Nishay. Whenever I ask you a question, you will have that confidence and boost. That's all, fine. Okay. Then I have the second heading of phases of cell cycle. Then I have headings of cyclins and cyclin dependent kinase inhibitors or the kinases, and you have cell cycle inhibitors, and always aligned with the clinical correlation. So if you structure your exams like this, right, it's much comfortable so that you don't forget anything. At the same time, it's the exam looks neat and professional, and it's always ending with clinical correlation, which means we are thinking in terms of your third year and final year as well, right? So like I said yesterday, it's a base between your pre and your clinical exam postings, right? And I will end up with two questions because you guys are definitely worried about next, right? How many of you guys are worried about next exam? Definitely this question must have come across your mind, like will I be able to perform well in next exam? Definitely, right? So we'll make sure that we'll plan for the questions also right from start. So if you start solving questions from today, by default, when you sit 3 years down the road, whatever exam it is, you'll be a champ in that, right? Definitely you can do that. Fine, start. No issues, Hari. If you are starting before the class, answer your lecture so your teacher becomes happy. That's it. Fine. So let's start. So I'm sure you must have heard about cell cycle. Have you had a brief understanding of the phases of cell cycle also in your first year? You must have, right? So the definition as per Robbins is, it's essential for an organismal development. By default, right? Good evening, Snehajit. By default, it is required for an organisms to develop, which means from a fetus to an adult. We grew from like 3 kg person to 50, 70, 80, 90 kg person. I need cells to divide. Tissue homeostasis, this also is very important. So can anyone tell me what does homeostasis mean? Dimesh, first year, no? Finish first year. Then let's come to this. Okay. What do you mean by homeostasis? You must have definitely heard about homeostasis in your physiology. That's one of the first lecture which comes. Homeostasis to maintain the equilibrium, right? I eat food, I discharge energy in the term of activity. That's homeostasis. Be it your water, be it your ion, the balance is homeostasis. The constant environment is homeostasis. Amazing, right? So when I say tissue homeostasis, when I fall down, can I say I will have tissue damage, injury by default, and replacement of the dead or the damaged cells? Whenever I cough, I'll have throat cells dying. My cells should be replaced back. That's tissue homeostasis, right? Cell cycle is very, very essential for a development of an organism, helpful for homeostasis or maintenance of the tissues, and also to replace the dead and the degenerating tissues. Fine, perfect, great. So I have to maintain the interior. Let's say that I gave an external injury of falling down. If your kidney has a damage, someone punched you, obviously internal organs also has to change. Or the best example, let's assume that you are reading today's cell cycle. Should I form new neuronal networks? Otherwise I will forget, right? That also is in homeostasis. For that also I would require cell cycle for that matter. Fine. Okay, super. Okay, so I'm sure you must have read about cell cycle. You must have drawn a diagram like this right from your UG days itself, right? So G0 is the resting phase. Then I have G1. What's the next phase? After G1, you have a phase called as S. Then you have a phase called as G2. And finally, you have phase called an M phase, right? I'm sure you must have known what does G1, S, G2, and M means primarily, right? Can anyone tell me what does S stand for? S stands for synthesis, the DNA synthesis, and M stands for your mitotic phase, right? Where it divides into two new cells. That's the ideal purpose of the entire cell cycle, right? What does G stand for? Can anyone tell me what does G stand for? Actually, S and M are the primary phases where the cell actually divides or cell does majority of the work, either synthesis or the division, right? So G stands for the gap. Ideally, it means that it's gap between the S and the M. Gap between the S and the M. That's what, right? G stands for the gap phase, not the growth. It's a gap phase, right? So we have gap 1, gap 2, and gap 0. And S and M are primarily the important ones, okay? Perfect, right? So let's see what are the important events in case of G1, G2, S, M, and G0 as well, right? Okay, can anyone tell me, we already know the importance of S and M phase, right? Can anyone tell me what do you think will be required for G1 or gap 1 before the synthesis of the DNA duplication? Any event which comes to your mind, if you have read before, please hear whatever comes to your mind, please tell me. There's no inhibition. I will never laugh at your questions. I will never laugh at your answers also. You can be open whatever comes to your mind. Tell me what do you think will be required for a cell which is going to synthesize the DNAs? Anything which comes to your mind. Gap ones, one of the important function is I have to increase the mass, the proteins, the energy, every organelle in sense, right? So because in your synthetic phase, I have to kind of duplicate it. You must have read about semi-quantitative replication of your DNA in your biochemistry, right? Whatever is required for me in that process, obviously I will be multiplying in the G1 phase, gap 1 phase. This is one of the important pointers. One more important point which is there for the gap 1 or the G1 phases, it is also required for the formation of the centrosomes. Centrosomes duplicate here. Centrosomes do not duplicate in the S phase, right? This can come in an entrance exam. Centrosomes duplication happens in the G1 phase. They don't duplicate in the S phase. Only the hardcore DNA, the chromosomes duplicate in the S phase, right? Perfect, right? So we know the function of the G1 phase. S phase, I'm 100% sure you know that, right? The chromosomal duplication is the main function in S phase. Again, I'm sure that you must have read about the lagging strand, leading strands, and this everything, right? So let's say that here I'll have, in short words, DNA or chromosomal duplication. The chromosomal duplication is the primary function of the S phase, fine? Okay, I'm just going to ask you a simple random question. I want you to answer, right? Let's go away from Robbins or pathology or medicine. I'm a person who feels that medicine is a way of living. If you can correlate things in your real life to your textbooks, you will never forget, right? Let's say that you go have a PT period, you go and play outside for 40-45 minutes. Am I right in saying you will be getting exposed to UV rays? Yes or no? Yes or no? You will be, right? Tell me, UV rays is an ionizing radiation or a non-ionizing radiation, right? Rudrajit can help us. It's way back in your physics. It's ionizing or non-ionizing? By default, it is an ionizing radiation, right? So if I say something as an ionizing radiation, can I say it can cause damage to my DNA? Ionizing radiation by default means that it can form the electrophilic adducts, right? That's what ionizing radiation means, right? So definitely it can cause damage to my DNA, right? All of us accept that, yes, it will cause damage to my DNA, right? Not cancer, we'll come to the Jaykumar soon, right? So now let's say that my skin, can I say my skin divides every single day? Yes or no? Skin divides, yes or not? Definitely it divides. If you have not taken bath for a day, have you ever rubbed? You'll have like tiny flakes coming out of the skin. Those are dead skin. Skin divides every day, skin dies every day. That's why if you don't take bath, you have all the things there, right? Perfect. So by default, my skin divides every day. By default, my skin dies every day, right? So a skin cell is always in the cell cycle. They are very labile cell. They're always in the cell cycle. So can I say, I'm just writing for an example, a UV exposed skin, okay? Just writing for an example, a UV exposed skin, is there a possibility for me for it to have a mutation? Yes or no? Right? Definitely possible for us to have a mutation, right? Now let's say this skin cell with a mutation is going into S phase. Will it divide with the mistake or will it divide without a mistake? I'm getting exposed to UV rays, I got a mutation and I'm going into cell cycle. The error will duplicate. Should that happen or it should not happen? It should not happen, right? That's why we have a checkpoint, right? I have a checkpoint here called as G1S checkpoint. We'll read about the checkpoint very soon because I do have by default pre-replicative errors. I gave an example of UV rays. UV rays are not the only thing which causes mutation. There are many things in my body which can cause a mutation, right? So I have a checkpoint to check for the errors, right? It will be in the Telegram group, Nawaz, fine? It'll be, you'll have checkpoints to check for the errors, right? Now let's go back to your biochemistry. Whatever you read in medicine will be useful. From anatomy till your psychiatry, it will be useful, fine? Okay. I'll come to Dr. Puneet. Have you read about methyl mismatch repair mechanism, nucleotide excision repair mechanism in your biochemistry? DNA repair mechanism? That's the one which acts here. So if my skin cell has a mutation due to UV ray, if it is a double stranded break, my nucleotide excision repair comes into play. My base excision repair comes into play. Based on the error, my repair mechanism will come into play and I will repair the DNA. Only then I will send them into S phase, right? That's the function of G1S. We'll look into G1S very soon in detail, right? So now I have gap 2. So S is not much of importance. Okay, S is not much of importance here. S is only for synthesis of duplication, that's all. Gap 2 for me is again to prepare for mitosis or to prepare for cell division. So what do I mean by preparing for cell division? Means I need to synthesize everything required for cell division, be it your mitotic spindle, be it your enzymes, be it your whatever proteins, right? Same way like gap 1, it's going to preparatory phase, that's all. Your mitotic spindles, all the chromosomal divisions, the cytoplasmic proteins, your organelles, everything should be duplicate, right? All of them will take care of this, right? So here again it's going to prepare primarily for cell division. I'm just giving an example of mitotic spindle. In other words, everything necessary for me for mitosis will be taken care of here, right? That's all. Now I come to mitotic phase or M phase. M is a very simple thing. You must have read about mitosis way back in your school's standard, right? What are the mitosis? Phases of mitosis. This is my famous question to all the students. What are the 4 different phases of mitosis? Rudajit, if you're still here, you can answer this question. You must have, definitely you'll remember, right? Prophase, metaphase, anaphase, telophase. All of you will remember this. You'll remember this till the end of your career. But if you actually imagine, when did I read prophase, metaphase, anaphase, telophase? If I go probe a little bit, you also will see Pachytene stage and everything. You must have read that in 10th, 11th, right? Have you forgotten? You're not forgotten, right? So can I say by default your memory is good? Yes? Tell me, have you felt every day in your first year or at least close to the exam, but my memory is very bad? You must have, right? You must have by default told that to yourself. You must have made you believe that my memory is very poor. I keep on forgetting things. If you can remember Pachytene, Diplotene, Lapotene, whatever it is, which you read in my 10th or 11th or 12th standard, and if you're not remembering anatomy, you didn't read anatomy, that's all. Your memory, my memory, every human being's memory is same. It's based on how you train it. Simple question. Please don't blame your memory. Your brain is amazing. It will remember if you read. If I don't read, let's accept that I didn't read and let's move on. That's all. Right? As simple as that, right? Mitosis, the cell divides. Okay. Now again, I'm going to ask you a question. Okay. So, do you remember your semi-quantitative replication of DNA? I won't ask much of the question, but still I'm sure you must have remembered, right? You must have remembered about your DNA polymerase enzymes and everything. Can I say that DNA polymerase, one of the activities in eukaryotic cell is proofreading? Is that statement right? The DNA polymerase will help in the proofreading activity Because when I am synthesizing two new strands of DNA, by default, I will have some amount of errors. So I have to check for the error. So I have a proofreading activity. Can I also say that this proofreading activity will not be 100% correct? Is there a possibility? Definitely there is a possibility because it's a proofreading activity, right? No proofreading activity will be 100% correct. It will have mistakes by default, right? So what happens here is, if I have any mistakes which has happened during the semi-qualitative replication or quantitative replication, it will be taken care of by this place. That's my G2M checkpoint. I have one more checkpoint between G2M. This is going to take care of the replicative errors. We'll see soon how it takes care of that, right? Any replication will have an error. So anytime when I have a replication, the error will be taken care of by G2M. So I'm just going to give an extra question for you, just for you to think. If replication will have error, when the replication is more, faster, the errors will be faster or the errors will be slower? What do you think? Just a random question. If there is more replication, will there be more errors or will there be less errors? Whenever you read something in MBBS, it has to relate to patient. That's all. You'll have more errors. That's it. Fine. Yesterday we read something called an normal endometrium proliferative phase estrogen, excess estrogen. We termed something called an endometrial hyperplasia. So can I say an hyperplastic endometrium which divides faster will have more errors than normal endometrium? Is it right or wrong? That is absolutely right, right? So if there are more errors, is there a chance of a permanent mutation? There's definitely a chance of a permanent mutation, right? Like Jaykumar said, can it result in a cancer? There is a possibility of a cancer formation, right? I'm not saying it will always result in a cancer, but please keep in mind, whenever a cell divides very fast, any cell from head to foot, if it divides fast, I do have a good chance of it becoming cancerous. Just for understanding, do remember it. That's all. Okay, perfect. G0 is an resting phase. Gap 0, where I don't do anything. There are few cells which will always be in gap 0, right? Gap 0 is a phase where I can kind of call it like an interphase. I'm sure you must have read about interphase, right? In your cell cycle, you must have read about interphase, a resting phase or a very silent phase. That's the role here. They are not involved in cell cycle. Okay. There are two types of cells which will be in the resting phase. One, it's partial resting phase, which means this can re-enter into the cell cycle when required. When needed, they go back into the cell cycle. One is a permanent resting phase. When it's permanent, they cannot re-enter into cell cycle, right? I'm sure in your first year, you must have read this, right? One second, Punit, I'll definitely answer your question. Tell me any cell which comes into your mind which never divides or they have lost the capacity for cell division. Neuron, right? Your neuron, your skeletal muscle. Skeletal muscle, as of now, yes, they can replicate to some extent. These are things which never ever can come back into my cell cycle. They are always in G0 phase. If there's an MCQ comes, a cell which is always in G0 phase, never enters G1, is a permanently divided cell or permanently matured cell, mostly neuron. If neuron is not the option, I can think of a skeletal muscle fiber, fine. Okay. See, replication versus duplication. More or less it's same. When I say duplication, I am going to divide a cell into two new halves and completely duplicate it. That's all. Replication is I need not always divide, like you must have read about your telomerase activity, right? There only one strand, only the lagging strand kind of lengthens. That I can use for the term replication, but more or less used synonymously, not much of a difference. But duplication is something which will make into two halves and make the exact copy in two halves, right? Replication is something, anytime when I have an error, I can cut that part and replicate that part alone, fine. Okay, let's go back to the next one. Okay, yes, to some extent, striated muscle fibers, skeletal muscle fibers, cardiac muscle fibers, both of them permanently remains in your G0, fine. Okay, now I have a cell cycle which has a very high capacity of errors, and like you guys said, it can cause cancer. So this cell cycle should be regulated or it should not be regulated. What's your take? If it's unregulated, that's all, right? Many errors will come, right? So I definitely need a very strict regulation for a cell cycle, right? Now, in your physiology, you must have read about endocrine regulations, right? Insulin regulation is something which you must have read a lot, right? So Nischay batch I'll take in app for 2 hours every day. This for 20-25 minutes. That's it. Fine. Okay. It'll be completely regulated. So can I say any regulation in my body needs both positive and negative? That's what regulation means. I need some people to drive the cell cycle. At the same time, I need some people to stop the cell cycle, right? That's how it is. The persons who drive the cell cycle are the cyclins and CDKs, right? These are the people who are going to drive the entire cell cycle. When I'm going to have a cell cycle, something which pushes them in the positive manner is my cyclins. They are proteins involved in cell cycle, so they are named as cyclins. Other one is CDKs, cyclin dependent kinases. Again, going back to biochemistry, what does kinase do? Anyone? We have cyclins and CDKs, cyclin dependent kinases. Okay, we have cyclins and cyclin dependent kinases, right? Kinases phosphorylate. Perfect. So cyclins are actually inactive proteins. Whenever I need them to drive the cell cycle, these kinases phosphorylate them, make them active, and then they drive the cell cycle. That's how cyclin works with cyclin dependent kinases, right? That's how they work, which means they always work together. They can never work alone. Cyclins alone not effective, CDKs alone not effective, but they are together, they are very effective, right? So there are few cyclins which I want you to remember. There are actually 4 cyclins. In the order I want you to remember: cyclin D, cyclin E. Okay, this order once came in AIMS exam, because AIMS had a, in between they had something called a sequential arrangement of MCQs. They go haywire every time, right? So this order might be required, fine. Okay, A and B, right? These are all cyclin names. Okay, I'm not much of a fan of a mnemonic, but if you want to remember a mnemonic on how to, like, is there any clue to remember this? Again, I am, for you guys, I'm taking my entrance exam time notebooks and try to create mnemonics. Cyclins do their job very boldly. Remember that, right? Cyclins, because they are very essential, they do D for your cyclin D, each action boldly. If you want, you can remember this. That's an order, right? So I have D, E, A, and B. This order is the order in which it's involved in the entire cell cycle, right? Or you can make it as D, E, A, B, not D. Okay, not Deb. Okay, it's B, my mistake, right? So D, E, A, B is the order in which the cyclins act, fine. So cyclins, like I said, they cannot act alone. They always require cyclin dependent kinases to act for them. CDKs always join with 2 of them, CDK4 and CDK6. Cyclin D is involved with cyclin dependent kinase 4 and cyclin dependent kinase 6. Cyclin E is involved with cyclin dependent kinase 2. Okay. A again has 2 cyclins, cyclin dependent kinase 2 and 1, and B has cyclin dependent kinase 1. As on date, there is no utility for remembering 4, 6, 2 and 1 unless and until your examiner or viva person wants to test you on the numbers. There is no clinical correlation for 4, 6, but D, E, A and B is required, and of these we'll see where they are involved, right? So cyclin D, E, A, B is there, and we have cyclin dependent kinases. And I have 2 checkpoints, G1S and G2M. These are to check pre-duplicative or pre-DNA replicative errors, right? And these are due to replicative errors. For me to look at a replicative error or errors which occur due to DNA synthesis or DNA replication, we look for that, fine. Okay, pre-replicative errors, I have G1S checkpoints. So these are checkpoints and these are cyclins, right? Now let's just draw an entire round to see where are these cyclins exactly involved, fine. I'll ignore G0, I have G1, we have S, we have G2, we have M, fine. So like I said, it's the same order starting from G1 only, right? It's always cell cycle starts from G1 to S transition, right? So if let's say this is two of them, this is my G1S gate, this is my G2M gate. So for me, a cell to move from G1 to S, I require cyclin D's and cyclin E's help. Okay, so I require cyclin D plus cyclin E's help. Fine. For me to smoothly transition from S to G2, right? Though there is no checkpoint here, I require cyclin DEA, cyclin A's help along with the CDK 2 and 1, right? And then for me to move from G2 to M checkpoint, I need cyclin B's help, right? Cyclin B. Okay, so these are the places where these cyclins are involved. Fine. Ask me what you want in Hindi, I'll tell in Hindi. Fine. Okay. Thoda weak, like Rudrajit said. Okay. So cyclins are this how they act, right? So now I'm just going to ask you one more question. If my cell came to G1 and I got cyclin D and CDK 4 and 6, cyclin E and CDK 2 went to S, automatically moves to S, right? So if there is a problem, let's say that I was in the UV rays and I got a mutation, I found that there's an error here. If there's no one to stop, will they automatically go to S phase? Am I right in saying that? Definitely, right? If there's no one to stop this error, it will automatically go to S phase and I'll have the mutation. So do I need some inhibitors? Required or not required? By default, I do require inhibitors, right? Because like I said, every regulation has both positive as well as negative feedback. This is the positive feedback. My cyclins and cyclin dependent kinase are the positive feedbacks. Who are the negative feedbacks is? That's where my cell cycle or CDK inhibitors come. Okay, now tell me, which can I inhibit? Can I inhibit a protein easily, or can I inhibit a kinase, that's an enzyme, easily? Which you think can be inhibited, cyclins or CDKs? Only kinases can be inhibited, right? Even in your physiology, when you read about insulin metabolism and everything, enzymes is always regulated because it's easy to regulate an enzyme than to regulate a primary protein, right? Perfect. So all the inhibitors act on the cyclin dependent kinases and not primarily on the cyclins, right? So I have cyclin dependent kinase inhibitors. They regulate the activity of CDK complex, but primarily they act on the kinases only. I divide the inhibitors into two major ones. Okay, the first one I call it an specific inhibitors. The other is non-specific inhibitors. I'll go back to the cell cycle once again. Of this, which gate you think is more important, G1S or G2M? Whatever comes to your mind. Which you think is very important here of these, G1S or G2M? What do you think? By default, G1S looks little bit more important, right? G2M is also important, but by default, G1 is little bit more important than G2S. Perfect. Now, cyclin D and cyclin E. What were the cyclin dependent kinases involved? G1 is more important because that's the first thing. G2M is also important. I'm not saying. Why I am not relying much on G2M is Gene Savvy and Souvik Datta. Like I said, whenever a DNA replication or semi-quantitative replication happen, I already have DNA polymerase inbuilt to check for proofreading errors. This is an extra support, that's all. But in G1S, that's a primary and only thing to check for pre-replicative errors. That's why G1S is a little bit more important for me than G2M, right? Okay. So now cyclin D is one of the most important enzyme and along with that kinase. So the first group of specific cell cycle inhibitors, they will target or they will inhibit only CDK4 and CDK6. In other words, they are going to primarily target my cyclin D's activity or my G1S phase activity, primarily on cyclin dependent kinase 4 and 6, right? And there are few inhibitors. It's specific, so remember it's the first group. Just a way to remember, because there are few proteins which I'm going to write. We have proteins named as P. Have you heard about P53? A protein named as P53. Have you heard about them? Yes, maybe. Like that, I have proteins called P15, P16, P18, P19, right? So all these proteins, thank goodness they didn't name them. They just, P15 means protein of 15 kilodalton weight. P16 means protein of 16 kilodalton weight. P53 means it's a protein of 53 kilodalton weight. That's all, right? So all of them with 1 is the first group or the specific group. I do have something called as very non-specific cell cycle inhibitors, which means they have the capacity to inhibit CD4, CDK4, CDK6, CDK2, 1, anything, right? They are very, very non-specific. They can inhibit multiple CDKs. They are non-specific. It's not specific only for cyclins, right? Cyclin dependent kinase 4 and 6, anything. Let's consider this a second group or the secondary group. Whichever P has 2 in the name, P21, P27, P57. All these comes in a non-specific cell cycle inhibitors. But I didn't talk here about P53. P53 is a big boss, like you guys said, gatekeeper, right? It's a guardian angel that can inhibit whichever it wants. Both this, everything. So we'll not come into the P53 now. We'll look at P53 sometimes down the road, right? So this is what cyclin dependent kinase inhibitor does, right? Let's go back to the cell cycle diagram once again. So here I do have 4 and 6, right? That's how it involves. Snehajit, the importance is cyclin D is something which is going to be involved with CDK4 and CDK6. And that is the primary regulator of G1S. So I need more protection for the G1S and more control over the G1S so that I have more control over cyclin D. That's why I have very specific and I have non-specific as well, fine? Okay. I hope you understood that, right? Here is where my CDK inhibitors will act. It can act here also, or in words, it can have a negative feedback mechanism here and it can have a negative feedback mechanism here as well, fine? So that's how it is regulated in a negative as well as in a positive way, right? I'm not very good in diagrams. If you're very good in diagrams, have a much more diagrammatic description, right? After this class, please go to Robbins. The beauty of Robbins is whatever we have read in Robbins now, maybe 20 minutes, can be covered in 2 flowcharts or 2 diagrams. That's enough. So when you read Robbins, make sure you focus on the diagrams, flowcharts, or any textbook. After reading the text, you read this, you will understand everything. Revision becomes much more easier than any notebooks, right? That's why it's important. But if you read only that diagram, you will forget. Okay, Harsh, I would say no, because you have many more important things than this. So maybe once you enter MBBS, come to second year, we'll definitely read again. Okay, now we know everything about cell cycle and its regulation. Now my only question is, why should a doctor know this? I always feel that if something is not important for me in real life, that's patient diagnosis, management, or prognosis, I don't want you guys to read. Never. Okay. I never want you guys to read. The next time do this. Why should a doctor read this? It should have some clinical correlation, right? If there's no clinical correlation, there's no fun in reading. Always end every 5-mark question or 2-mark question or essay question with clinical correlation, right? So by default, I have 2 groups of proteins here. One is cyclins, I have CDKs, and I have cyclin dependent kinase inhibitors. So can I say all these are involved in regulation of the cell cycle? To know the stage of any disease areas, they are involved in the regulation of cell cycle, right? Cyclins and cyclin dependent kinase are involved in a positive way. Cyclin dependent kinase inhibitors are involved in a negative way, right? Okay. Now, if I have a mutation, what do you understand by the term mutation? Anyone? Whatever you read from your biochemistry, what do you understand by the term mutation? Mutation means it's an alteration in the DNA which codes cyclin or which codes cyclin dependent kinase, right? So tell me, if I have a gain of function mutation, can it cause more cell division? Is that statement right? Definitely. Or if I have a loss of function mutation, right? So either a gain of function mutation of a cyclin or a loss of function mutation of an inhibitor, which means there's no one to inhibit. So I keep on dividing, right? So by default, this can cause an abnormal growth. Neoplasia is a very right term, fine. So this is called as an abnormal growth. I'm just naming them for now. An abnormal proliferation. I'm not going primarily into cancers now. Yes, they do cause cancers, but an abnormal proliferation, fine. Rudrajit, drift and mutation, there are many things to tell you before talking about drift and mutation. Maybe you ping me later on, I'll definitely talk about drift and mutations, fine? Okay, so this can cause your errors or an abnormal protein. That's the first thing. Second, like I said, there are few cells which stay in G0 phase always. There are few cells which are partially in the G1, G0 phase, and there are few cells which are always in cell cycle. It's always cycle independent kinase inhibitor, Sovik. Fine. Okay. So here there are cells, we call them as a labile cell. A labile cell is always there in cell cycle. Right? I have a cell called a stable cell. Stable cell are something which is there partially in your G0 phase, right? Or in other words, they can come back after a trauma, partially in 0, and I have something called a permanent. A permanent cell which is always in the G0 phase, fine? So why do I need to know this is the next question, fine? So here, a labile cell is always in the cell cycle, like my skin. So now tell me, if you have a trauma, you must have cut your skin, right? Definitely by default in the 20 years of your life, you must have cut your skin at least once. If you not cut your skin, now at least get an injury. Can I say a skin cut can heal very quickly and without a scar formation? Is that statement right? It's always right because they replicate faster. They can replicate very fast because they are always in the cell cycle. They are always in cell cycle. You must have pricked, you must have cut. It will replicate without an injury, right? Without a scar formation, right? So any cell in the cell cycle will always replicate fast. Okay, replicate fast and heals without an injury. Ravi, my Hindi is a little bit of problem. So I'm trying to learn. Hopefully in the next batch with your guys' help, I'll speak a little bit of better Hindi. Okay. You ask me a question in Hindi, I can understand. हिंदी के प्रॉब्लम टू चीज़ है, एक जेंडर का प्रॉब्लम है और एक टेंस का प्रॉब्लम है. This problem reduces my confidence, reduces my flow. That's why I talk in English. Fine. Okay. Stable cell can replicate, but they will have scar tissue. The chance of scar formation may be there, may not be there, based on the extent of damage. But a permanently divided cell will always end up in scar. Always will have scar tissue. Even if it's a tiny problem, it will have a scar tissue, right? That is why MI or myocardial infarction is very dangerous for me. If my skin dies, no one cares. It will come back by default. If my liver dies also, it can come back by default. Fine. I'll talk slowly, Ravi. If you have any concern, do let me know. I will repeat it. I'll talk slowly for sure. Okay. So if I have any injury to heart or to the brain, it will always end in a scar. If I have an injury in case of a skin, it replicates faster, right? So these are two applications of understanding the cells in different parts of cell cycle. Fine. I hope it's clear. Ravi, you can ping me later on if you don't understand anything. I'll definitely reply. But talking in Hindi, it'll be worse than my English. That's my only concern. Okay. No one is going to poke the nose till the all cribriform plate, right? Unless you're going to poke the nose completely till the cribriform plate, it will cause anosmia forever, right? You cannot go beyond your inferior turbinate. Reaching middle turbinate itself requires an instrument. You can go maximum till the inferior turbinate, and olfactory nose don't come till the inferior turbinate, right? That's why. Okay. But if you have a cribriform plate injury, fracture, that's possible in trauma, and if olfactory bulb has been resected, you will end up in having permanent anosmia. Fine. Okay. Right. That's what in short is about cell cycle, right? Now let's try to apply these both, whatever we read, to a question. And after this video, I want you to go back to your Robbins and read a little bit of it, maybe 10 minutes, read that. You will definitely understand that Robbins is easy and cell cycle is also easy, fine? Okay. Read the question carefully and then tell me the answer. It's okay. Some of you might read faster, some of you might read slow, but don't look at other people's answer. I just want you to remember what is your answer. If it's wrong, it is completely fine. Okay, others. Jay Kumar has gone with C, Snehaj with C, Jane Medico with B. B, S phase. Okay, let's read the question. A 35-year-old woman presents with rapidly growing mass in the breast parenchyma, most likely a breast cancer, fine, and it confirms an highly malignant tumor. Immunohistochemistry reveals overexpression of cyclin D1, which means there is something which is being overexpressed. Cyclin D1 is being overexpressed, right? Which phase of the cell cycle is most likely to be disrupted in this patient due to cyclin overexpression, right? Okay, so we read that from G1 to S phase transition is where I require cyclin D1, right? So which is disrupted? Actually, is the G1S gate that is actually disrupted, right? If I want to choose one of them, I will choose G1S and not S phase, because for S phase to happen properly, I'll go back again. For S phase to happen properly, I need these cyclins. They are more dependent on this compared to this. For my G1 to complete and move to S, I want cyclin D. For my S and G2 to go smoothly, I would require cyclin A and CDK1 and not cyclin D. Cyclin D is more towards the G1. The right answer would be G1S, but G1 will be an appropriate answer, right? The reason why I said doing MCQs helps a lot is, one, it's always choose the best answer. It's never right answer. You will have questions like this, cat on the fence, right? You will have questions where both answers, both options might look right. The better answer here is G1 compared to S, so I'm choosing G1. But the best or the right answer would have been G1S checkpoint, right? It's always choose the best answer. It's never the correct answer, right? Okay, next question. I'll do gene saving. What's your answer? I'll answer your questions, Snehajit. This is a little bit of much easier one, right? Cyclin E is definitely going to be involved in the G1S checkpoint. Both cyclin D and cyclin E is going to be involved in the G1S checkpoint, right? Let's go back here. So when you deep dive into cyclin D, can anyone remember what are the CDKs involved in cyclin D? I told there are two CDKs involved in cyclin D. What were they? Two CDKs involved in cyclin D. It's CDK4 and CDK6. These are the two CDKs involved in cyclin D. Perfect, right? Okay. So if you look at the cell cycle, let's say this is the exact checkpoint and this is my G1, this is my S, right? Let's assume like that, fine. So when you look at the transition, the cyclin D along with CDK4 will be involved in the latter half of G1, and cyclin D with CDK6 will be involved in the transition and a little bit of early half of S. This is how the entire thing will be, right? So if I take cumulatively, the impact of cyclin D on G1 is a little bit more than the impact of cyclin D in S. In S, it's more of A. Cyclin A plays a more important role. Again, it has two CDKs, 2 and 1, right? A is more important for the S phase, and D and cyclin dependent kinase 4 is more important for the G1 phase. Clear, Snehajit? And who is that? Gene saving. Clear? Fine. Okay. Yes, it will be. We can take an end of G1 and G1S. Yes, Snehajit. Okay, fine. So that's all for today. See you tomorrow with the next CBME topic, which is your stem cells, right? Stem cells might look very exciting, but let's see if it's really exciting and it has something in future for us to stand and in terms of treatment, fine. Again, same tomorrow night. I'll try to put the notes for this in the group as well as in the Telegram group of PW, and also I'll put the workbook for tomorrow's class by tomorrow in the morning, fine. See you guys tomorrow. Bye bye. Thank you for your time. Please go back to your book We have still 9 to 10 is our time, right? We still have 15 minutes. Go back to it and read it. MAMC or VMC? Me? No. Robbins, I don't have the book of Robbins here in my tablet now. I'll definitely take tomorrow if possible. Fine. Okay, I am neither MAMC or VMC. I did my UG from Kilpauk, Chennai, and PG from Jimma, Pondicherry. That's why the problem of Hindi. Okay. Fine, guys. See you. Thank you. Bye bye.